In this module, you will learn about the composition of functions. Suppose you're at a furniture shop and the shopkeeper is giving a discount of 10% on the purchase of furniture exceeding 5,000 rupees. You purchased furniture worth 8,000 rupees from the shop. Can you calculate the discount that you will get on this purchase? A simple and straightforward approach is to first calculate the amount on which the discount is applicable. This you get on subtracting 5,000 rupees from 8,000 rupees, which gives 3,000 rupees. Next, 10% discount is given on this amount. The discount is 300 rupees. Let us now derive a formula to calculate the discount if a purchase of X rupees is made over 5,000 rupees. In the first step, we have to find the amount applicable for the discount. This we get on subtracting 5,000 from X. Let G be a function from R to R, defined by G of X is equal to X minus 5,000. And then, in the second step, we have to find the discount. Let us define a function f from R to R by f of X is equal to 10% of X. This function will help you to find the discount that a customer gets on the amount exceeding 5,000 rupees. By combining functions f and g, the discount on a purchase of over 5,000 rupees can be calculated. This leads to the definition of composition of functions. If f is a function defined from a to b and g is a function defined from b to c, then the composition of f and g is a function defined from a to c, denoted by g circle f, and is equal to g of f of x for all x belonging to a. In the above case, the purchase is of 8,000 rupees. So taking x as 8,000 rupees, the composition of g and f at x is equal to 8,000 is equal to f of g of 8,000. Now, g of x is equal to x minus 5,000. Therefore, g of 8,000 is equal to 3,000. Now, f of x is equal to 10% of x. Therefore, f of 3,000 is equal to 10% of 3,000, which is equal to 300 rupees. This is the discount. Some important points to remember while forming a composition of two functions are: if f is a function defined from a to b, and g is a function defined from b to c, then the composition of f and g is a function defined from a to c. The function g circle f is possible only if the range of the function f is the domain of function g. When g circle f is possible, f circle g may or may not be possible. If both g circle f and f circle g are possible, then they may or may not be equal. Does the composition of two functions f and g in different order affect the result? In other words, does the composition of two functions satisfy commutative law? Let's see. Define functions f and g from R to R such that f of x is equal to 2x and g of x is equal to 3x square. Let's find the composition of functions f and g first, and then g and f. G circle f of x is equal to g of f of x. Substituting the value of f of x, which is equal to 2x, this gives g of 2x. Now, g of x is equal to 3x square. This implies that g of 2x is equal to 3 multiplied by 2x whole square. Hence, the value of g circle f of x is equal to 12x square. Now, let us find the composition of g and f. F circle g of x is equal to f of g of x. Substituting the value of g of x, which is equal to 3x square, this gives f of 3x square. Now, f of x is equal to 2x. This implies f of 3x square is equal to 2 multiplied by 3x square. Hence, the value of f circle g of x is equal to 6x square. Observe that g circle f of x is not equal to f circle g of x. Hence, we can say that two functions g circle f and f circle g are unequal. Hence, we can say in general that the composition of functions does not satisfy the commutative property.